Hey gophers, welcome to CoddingAdda. Today we will implement one design pattern in Go, that is factory design pattern. Let me explain what is factory design pattern. Factory design pattern is used to get actual implementation types instance in your program. Don't worry, it will be clear. Let me give you one example. Let's say we have one online examination portal where the candidates can write their program in three language. Either that will be in Golang, either that will be on CPP or Java. So we support three languages to write any program. We have a contract, and this three type implements this contract. This contract probably we have one function that is compile. So whatever the program the candidate will write, then that program will be compiled in any one of this language. Let's say candidate choose that he or she want to write the program in Golang. So we have that value in a variable that is chosen by the candidate. So we know that candidate choose Golang. Based on that value, we will evaluate candidate's program in Golang compiler. Our factory method's responsibility will be to get us the exact type of lang contract which will be used further to compile the candidate's program. So this is our factory function which will take input of lang time that will be chosen by the candidate, and our function will take this as input and it will give us one of this three compiler instance. This is the factory design pattern. Now we'll implement the same concept in our Go program. So let's do that. So first, what we have to do, we have to create one contract. In case you haven't watched my interface lecture, please go back and see that and come back here to understand it very clearly. So this is our contract. Here and this ilang, this is basically ilang. Here we will define all the functionalities, all the function that any language should implement. Then only we can tell that language is promoted to this type. So what we have to do? First, we have to create one interface type and we have to define all our contracts, all our functions here. So it should have one get name function, set name function, compile function, and runtime function. Now, this is our contract. Now, what we are doing? We are creating one lang extract type. Here we are telling that name. It should have one name field. Now, what we are doing? We are implementing this four methods on type lang, on this lang struct type. We are implementing all these four methods. Later we'll go to the detail logic written inside here. Now let's understand we are implementing this four functions on this lang type. Now what we can say, this lang type is promoted to ilang type. So all the other types that will implement this lang type will also be considered as ilang type. Now we will define our this tree language. We have defined Golang, another type, struct type. Then we have CTP, another struct type, and we have Java, another struct type. And what we are doing in Golang, just we have created one function new Golang, which will give us one instance of Golang type. Golang, and we are passing lang name colon Golang. So what we are doing? We are creating one Golang here, and we are returning address of that. So we are creating one Golang this type here, and it will be the as same contract of lang this struct. That means what we are telling, Golang is actually promoted to ilang type because it's following the lang, and on lang we have already implemented all this functions. So actually now we can tell that Golang is a type of ilang. Now here we are creating one instance you can think of, where what we have to do, as it follows lang, then we have to pass name here. That's why basically we are creating one lang with name fill, and we are setting in that in Golang, because Golang is following the type lang. That means we can say that a Golang type has a field name indirectly. So what we have to do? We have to set this lang in Golang. So we are setting lang, and lang is nothing but another type. So we are creating that type here, and in that lang type we have name. Similarly, in case of CPP, we are doing same thing. CPP. We are creating one CPP here, and we are setting this lang. Lang is again, lang has a name. And in case of name, we have passed here Golang. Here we have passed CPP. And in case of new Java, we have passed Java. So if I summarize what we have done here, this may seems little complicated. Let me summarize. On top, we have one interface. Below this interface, you can imagine here we have one struct, that is lang. This is lang interface. Here we'll have lang struct, then all three struct are there. So hierarchy is lang interface, then lang struct, then actual concrete implementation, Golang, CPP, and Java. So in this lang interface, we have defined that it should have these four functions. Now we are creating its one implementation in the lang struct. That means this lang struct should implement all this function. Yes, and it does that. Now lang is the one you can think of abstract implementation of this ilang interface. Now you will create concrete implementation, that is Java, CPP, and Golang. So if we create now concrete implementation, this Java, CPP, and Golang should implement this lang. That's the thing. So that's why what we have done in the concrete implementation, we have mentioned lang only, lang stack. So this is following lang stack. It has only one field of which name is lang and which type is lang basically. This is the main. Okay. So similarly in CPP also lang, and similarly in Java also lang. And we are one method for each of this struct, new Golang, new CPP, and new Java, which are creating the concrete instance of this type, and it's setting the lang variable here, and lang is a type of struct. That's why we are creating that struct here. I hope it's clear. Now we have the factory method, that is getLang. That's one, and it's accepting one lang type user input. It can have the string like Golang, CPP, or Java. Based on this, we are checking if this is Golang, then we are creating instance of Golang language. If it's CPP, then we are creating instance of CPP language. And if it's Java, then we are creating instance of Java language. And this language have one method we know compile, right? So now what we are doing, we are calling. So this is we are returning this. If any error, then we are returning error. Okay, and ilang the type is nil. If not, then we are returning from individual condition that ilang type, because this is now of type ilang, because there's CPP or Java or Golang implemented lang, lang implemented ilang interface. So that's why the type return type he has mentioned is ilang and error is null. Now what we are doing inside our main function, we are getting two output ilang and error. Error will be null, and if error is null, then we are throwing some panic, can get language, concrete language. If not, if we are getting the instance, then we are calling this.compile. We know that it should have one compile method. So here we will got the actual output. Now we are passing CPP as an input here. Let's execute this. The output is compiling by CPP compiler. Okay, CPP. If I pass it as this one, Golang, then what we'll get? We are getting compiling by Golang compiler. So its actual compiler is used based on the language chosen by the candidate to compile. And why we are getting this output inside compile function, we have written compiling by percent is compile. This will be CPP, Golang, or Java. And we are using here l.getName because we should know that it has a name, and we are calling this here l.getName. I hope this is clear. This is little complicated. I tried to explain it very simpler manner. Let me know if you have any question in the comment. If you like Please subscribe to get the updates. That's all for this lecture. Thank you.